Welcome to another exciting maths video brought to you by Up Vision Concept Academy. If you are new to this channel, please subscribe, hit the subscribe button and turn on your notification bell so that we'll give you more videos. Today, we'll be continuing our JAMB Past Questions Mathematics. Our sampling year is the 2010. Number 30 says if you have a cyclic quadrilateral like this, actually it's a cycle and there's a quadrilateral inside where each vertex touches the circumference of the circle. So I have this like this, T, U, W, and V. These are the vertices of the quadrilateral. So if this side angle 3x plus 20 and this side is 88 degrees, these are all in degree. So we are asked to find x. So let me make it clear. This is 88 degrees and this is 30x plus 20 degrees. Now, the sum of angles or sum of opposite angles in a quadrilateral or in a cyclic quadrilateral is 180. So therefore, this and this, let me put it this way, angle TWV plus TUV is equal to 180. This is the formula. So therefore, TWV, this angle is 88 degrees and TUV is 3x plus 20 degrees is equal to 180. So I will do the collect like terms. 3x on this side, 180 minus 20 minus 88. So 3x is equals to, by the time I solve this, I get 72. And x is equal to 72 over 3. Therefore, x will be 24 degrees. So 24 degrees is the value of x. 24. So if I just put 24 here, let me just put degree first because everything is degree. Put 24 here, I can now get what x is. Okay. All right, the next question, quickly, 31. Number 31. It says, if two small sides, if the two smaller sides of a right angle triangle are 4 cm and 5 cm. Find its area. Okay. So why are they using the language, the term two smaller sides? Because the bigger side of the triangle is the hypotenuse. So they have just told you that this side is 4, this side is 5. That's what they have told you. So what is the area of the triangle? What's the area of triangle? Triangle. Area is equal to half base times, and this is the simplest question in JAMB. This year, that is the simplest question. Except you don't know the area of a triangle. Half times 4 times 5. Answer, 10 cm squared. Simplest question. 32. So 32 says an arc. An arc. We just uploaded this video today. As at the time of recording this one, I'm going to be uploading. We just uploaded this video on arc and sectors. Okay, so subscribe to our channel so you can be seeing the videos where all these topics are explained. They are explained. We are just solving it, and as we are solving it, it's based on the fact that you have already known some of these things. Though I will still have to break it down for us, for us to remember. So please subscribe to our channel. Just as you are watching this video, just go to the subscribe icon and subscribe. Comment. You can ask questions on this particular video. Put it in the comment section. We would attend to it. Okay, I'm trying to copy out the questions for us. Okay, so the question here says, an arc subtends an angle of 50 degrees at the center of circle radius 6 cm. Calculate the area of the sector formed. So let me visualize this. Look at the circle. Center. Understand? So there's an arc like this. If center is O, understand? The angle that is subtended at this center is what? 50 cm. And the radius is what? It's given as 6 cm. They say find the area of the sector. So this sector now, I can shade it like this. This sector should find the area of the sector. So area of the sector is theta over 360 times pi r squared. So theta is 50 degrees over 360 times pi 22 over 7 times 6 times 6. So this is what we are going to be solving. So this can cancel this, these two can cancel these two. So my final answer, theta, is 110 over, area, 110 over 7 cm squared. In fact, this is how they left the answers in the options. One of the options, this is how they left the answer. So we are actually solving 2010 question and type B. If you get type B, this particular question, this is how they left the answer in the options. Okay. So the next question is number 33. Number 33. So if you're having difficulties, you can pause the video, rewind, check again, go over it, you'll get it. Or you can leave a comment in the comment section where we can attend to you and we'll know the direction, how to explain better. Okay, a cylindrical pipe 50 cm long with radius 7 cm has one end open. What is the total surface area of the pipe? So this is the pipe. This is the pipe, 50 cm long with radius 7 cm. 50 cm long with radius 7 cm. So let me just visualize it by drawing. I'll just explode it like this. This is the pipe. The radius is 7 cm. The radius is what? 7. So radius from here to center. This guy is 7 cm. This length, this radius, and the length the length is what? 50 cm. So find the surface, total surface area. We have done this before now. Check out our video. Check out our video. We won't derive the formula for surface area of a cylindrical pipe. But look at what these guys are saying though. They said has one end open. Okay, let's derive, let's just recap what we did in that video. But you can go and check the video, go and watch it and like it for me. So look at it. Total surface area. You know, we're going to, this cylinder has three components. It has this side, which is a circle, and this side again. Let me do the hidden details. It's a circle here. Just imagine there's a circle here, circle here. So for a total surface area of a closed shape, you have a pi r square of this one. This one is the area of this side. And because it's 2 of it, that's why we have 2 pi r square, 2 area, this area and this area together, times 2, that's 2. You understand? But this curved surface, if you unwrap it from a cylinder, once you unwrap this side to make it a plane, a 2D plane like this, if you unwrap it, it will form for you a rectangle. And this side that is going up, that you have unwrapped like this side that you open out for unwrapping, this side is actually a circle. The length of that circle is the circumference. And already, circumference is 2 pi r. 2 pi r. You understand? If you unwrap this one, this curved side, it will form something like this. Where this side and this side is this side, normal. But this side is actually the open side of, when you open the circle. This one, if you wrap it back, it will form a circle. So this side, that is the length of the circle, is actually the circumference. That's why I have 2 pi r. So this side is 2 pi r for this side, and this side is the length or height. Length or height. So the area of this one, this curved area, is this side, length, and this side. This times this, that's the area. So it is 2 pi r L or h, as the case may be. So this is the curved surface area, total surface area of a cylinder. But this is our cylinder that they gave us, so they say one end is open. That means this one is open. I don't have anything here. So I'm not finding any area here. So this one, these two will disappear. These two will disappear. So it's only one of it I'm considering, plus 2 pi r L. So this is the formula of what we're going to do here. That's why you have to know all these things from principle, from basic principle, from foundation. What's common here in this formula? What's common here? R pi is common. Pi r is common. R plus what? 2L. R plus 2L. At this point, what's our R? R is what? 7 cm, and L is what? 50 cm. Okay. All right, so we continue, we move. I'm just trying to study the question again. We move. So this is pi times r, 7, into 7 plus 2 times 50. So this is 7 pi into 7 plus 100, 7 pi into 107. So when I multiply this one now, this is 49 and 7 by cm square. So this is the answer. If I express pi as 22/7, you can further, depending on what you have on your options. So, but this is the answer. This is the answer. But what I'm testing you here, first of all, is to identify your parameters. Know which one is length. This is the length. Know which is the, what they call, the radius, the distance. Then they now put a trap here and say one end open. I'm sure in the options, by the time if you go and use this formula, you will see the answer in the option. Meanwhile, we are told that end is open, so I'm not considering this side in the formula. I'm considering only this side and this side. All right, so let's continue. Let's continue. We'll go to 34, number 34. Number 34. So it says, what is the locus of points that is equidistant from points P and Q. So what is the locus of points that is equidistant from points P and Q? You see all these things that we have here as locus, they actually point on the Cartesian plane. If, for instance, I have a Cartesian plane like this, you know, this is my y and this is my x, and this is positive y, negative y, positive x, and negative x. So if point P is, this is x and y, x is 1, y is 3. This is point P here, 1 and 3. And Q is what? 3, x is 3 for P, x is 3, and y is 5. So y goes up 5, maybe 5 here. This is another one. Let me put it 3 here. So this is Q, 3 and 5. So these are actually Cartesian. So these are the 2 points I'm considering. Understand? So what is the locus of points equidistant from this and that, from P and Q? So, well, the first thing you have to do is to get the midpoint of the line segment. The midpoint of line segment. Okay. The midpoint of line segment connecting the 2 points is given by, so M is the midpoint. M is given by x1 plus x2 all over 2 and y1 plus y2 over 2. So if we are considering point P 1, 3 and point Q 3, 5, this is x1, this is y1, this is x2, this is y2. Mapping. So substitute in there, so substitute. So that midpoint, when you see x1, you put 1 plus x2, that's 3. 1 plus 3 over 2. Then y1 is what? 3 plus y2 is 5 and 2. So this is the midpoint. This is the midpoint of these two. Midpoint is the middle of these 2 points. There is another point again. These are Cartesian points. So another point. So from here, M midpoint is 4 over 2 and 8 over 2. So midpoint is 2 and 4. So midpoint is 2 and 4. So having gotten this midpoint, that midpoint now will now form a gradient. You understand? So this is the midpoint, 2 and 4. So the slope of n of a line passing through 2 points is given as slope. Therefore, slope is given as y minus y1 over x minus x1. So that slope is let me just extend the line to make us understand this thing. It's for these two. So slope is equals to 5, which is this 5, minus 3, which is this 3, all over x, which is this 1, 5 minus 3, this is 3, 3 minus 1. So slope again is equals to 5 minus 3 is 2, then this is 2. Slope is equals to 1. So I've gotten slope, I've gotten midpoints. I've gotten slope, I've gotten midpoints. So now the perpendicular bisector has a negative reciprocal. Understand? The question says we should find the locus of point that is equidistant. That locus of point is a line segment. It's a line segment. It's a line segment. So we have gotten the slope, we have gotten the midpoint. Now, what are we going to do? Let us now find that equation of that line. So let me take this one off. My midpoint in my slope is here, so I don't need anything again. Take this one off. So if the slope is this one, that's locus slope. The locus, the slope, you understand, which is this one, form a line equation. Form a line equation. You know, if we have this kind of equation, y is equals to mx plus c. C is the constant, m is the slope. You understand? These two are the variables. We have gotten the midpoint already. That midpoint that we have gotten is x, that's x and y, and the slope. You understand? So if we substitute the midpoints 2 and 1, these are the coordinates 2 and 1, 2 and 4, then the perpendicular of slope is actually minus 1, and the perpendicular of slope is equals to minus 1. You understand? So you now have it as y minus, this is x, this is y. Y minus 4 is equals to, I'm getting this one from here. This y actually is y minus y1 is equals to m, then x minus x1 plus c. This is where this one came from. This y can be, because this y actually is a difference. This is difference of y and difference of x. You understand? So I have y is minus, the y1 is the midpoint. The midpoint has two coordinates, x and y. So the y portion of the midpoint is 4, and the slope, which is the perpendicular, because we are looking for equidistance from the midpoint, is minus 1 into x is what is unknown, but x1 is the first coordinate of the midpoint, which is 2, then plus c. So at this point again, we just expand. Y minus 4 is equals to minus x plus 2. Minus x plus 2. We can remove the c because it's just a constant. So at this point, we collect like terms, or we'll just make 4 come to the other side. Let me wrap up here. This is the equation I'm looking for, but I want to simplify it. So y will remain at this side. Then minus x will be here. Then when 4 crosses, it becomes plus 6. So this equation is what satisfies that midpoint. What is the locus of point that is equidistant from this point? This equation satisfies that this condition. First of all, what you do is that you are given 2 points. You are given 2 points with their coordinates. You are given 2 points with their coordinates. You now say, what's the locus of the point that is equidistant from the two of them? Now, the first thing you do is to find the midpoint. The midpoint is actually the mid of by the coordinates. So this is xy, xy, xy. Find the midpoint, the mid of x. This is x. 3 plus 1 is 4 divided by 2. You understand? That is the coordinate, the x coordinate of the midpoint. Then 5 plus 3 is 8 divided by 2, which is 4. 4 is the y component of the coordinate of the midpoint. So we have 2 and 4 as midpoint. Now the slope, you get the slope again. Slope is just change in y over change in x. You understand? We got the slope as minus 1. Sorry, as 1. But because it say it is equidistant, you understand? It is now perpendicular. That slope now becomes minus 1. That slope and the midpoint coordinates, what we use in getting a new equation. You know, slope is actually in physics, when they say slope is changing the y-axis and the ratio to change the x-axis. That's what slope is. Okay. All right, so this equation satisfies that answer. Okay, we still have more on Cartesian plane and distance. Let's just do this. So number 35, it says find the distance between the points half, half, and minus half, minus half. Okay. So these 2 points, they are also Cartesian. So this is the x value, y value of this point, and x and y of that point. So find the distance. Distance actually, distance d is actually change in y over change in x. Sorry, that's not the formula. Hold on, let me derive it from the beginning. Distance is like the hypotenuse of those 2 points. Let me just derive it from the beginning. If, like I said, the previous question, again, Cartesian plane, you understand? This is y-axis and negative y. This is x-axis and negative x. Okay, so if, for instance, now, they say this first point, this is the x coordinate and the y coordinate. This point now, let's say this point is point A. Okay, let me actually use what is here. This is half. Let's say this is half. This is x half, y is half. If you extrapolate this like this, you get this point here. So this is, let me say this one is point A, and this one is point B, and this is point A. Now point B is half x minus half here, and this one minus half again, minus half. So let's say this is the point, this point B. So they say you should find the distance between these two like this. So if I just, after getting this 2 point, if I just make this one like a right angle triangle, and call this one point C. So distance actually is AC square plus BC square is equals to AB square. So this distance of these 2 points, which AB? AB is equals to square root of line AC square plus line BC square. That's the distance. That's the distance. But already you are given A as half, and I want to look for a way to explain this very well. Okay, so this AB distance now is equals to square root of x2 minus x1 square plus y2 minus y1 square. So we are looking at yy, the difference, and xx, the difference. So anytime you see something like this, you understand, this is how I derived it. But anytime you see something like this, you just identify which one is x, this x1 and this y1, this x2 and this is y2. So just look for this and this, difference between this and this square plus this and this square. That's what happened here. So D is equals to square root. The change in x is what? Minus half minus 1 over 2 all square plus y. Y is minus half minus 1 over 2. So D is minus half is minus 1. Minus 1 all square plus the same minus 1 again all square. So D is equals to 1 plus 1 all to the square root, and D is equals to 1 plus 1 is 2, root 2. So root 2, D is root 2. That's the answer. So this one is just, by the time you watch the video on this one, you see how it's being derived. But this one is just to tell you that, okay, what they did there was Pythagoras theorem. We are looking for the hypotenuse. So the difference, the x difference, this x difference, and the y difference, you understand? That's the whole of here to here is a difference. You have to find the difference between these two and these two. The way you difference, just add it, square each value and add to get this one square. You understand? But you know the square roots of everything. After you just do, just look for the what's it called, solid formula. Remove the square sign here. That means you are going to have a square root over, and you solve it. Okay, quickly we go on to the next one. The gradient of the line passing through points P and Q. Let's find the gradients. You see how these questions are structured? When they come to a topic, they just pick all the questions on that topic. So it says 36. Find the gradients of the line passing through the points P and Q. Again, the formula for gradients Formula for gradient passing through these points. Formula for gradient gradient M is equals to change in Y over change in X. So from here now, this is X1, Y1. This is X2, Y2. That's on the question. So gradient is equals to change in Y is Y2 minus Y1 over X2 minus X1. So what is X2? What is Y2? 5. N is equals to 5 minus Y1 is what? 1. Then X2 is 2. See where my hand is pointing, 2. And X1 is 1. So 5 minus 1 is 4. 2 minus 1 is 1. So gradient is equals to what? 4. That's the answer. That's the answer. Okay. 37. Number 37. 37 says, find the equation. Find the equation of a line parallel to y is equals to minus 4x plus 2 passing through 2 and 3. That's the another coordinate point, passing through 2. So find the equation of the line parallel. Okay, so now already this line is given. The gradient of this line is 4. Gradient of line is minus 4. How? Because this coefficient of x is the gradient. Sorry, the gradient. Now this same gradient is also the gradient of this other line. Why? Because they are both parallel. And I said the equation of a line parallel to this. Find the equation of a line. We're looking for equation of this line parallel to this one. So if this one gradient is 4, this one is also parallel. It's also the same gradient as this equation we are looking for. You understand? Now, passing through this one. So they gave us 1 point. They gave us 1 point of this equation. So we can find it now. We can find the equation. We have the gradient already. We have 1 point. 1 point. Understand? We have 1 point. So we can find it. Now, because the point is given, the point is given. So the equation of that line, equation of line is actually this. Y is equals to mx plus c, where c is constant. Where c is constant. Now we're given 1 point that is passing through, and we're given the gradient. So it's actually, by the time we put the difference, y minus y1 is equals to m, open bracket, x minus x1. This c will disappear because there are 2 points given there. No need for constant. So y is unknown. But we're given a new y, a y from the line, the point passing through. That is x. This one, 3. See, this is x, this is y. 1, 1. So we're given y1 here as 3. Y minus 3 is equals to m is minus 4 from here. Then x minus x1 is 2. So from here we can find the equation now. We just open the brackets. Y minus 3 is equals to minus 4x. Then this one is minus 8, because 4 times 2 is 8. So y is equals to minus 4x. Then when some crosses, it now becomes minus 8. Sorry, This is plus 8. Plus 8. Why? Because minus 4 minus 2 is plus 8. So this is plus 8 plus 3. So y is equals to minus 4 plus 11. So that's the answer. That's the equation. This is the equation of the line parallel to this. So this one and this one, they are parallel. See, they have the same what's it called, the same gradients. But this point has made these two to be different. Okay. So let's move on to number 38. Number 38. Number 38. If cot theta is equals to 8 over 15, where theta is an angle, is acute, not acute, not acute, acute. Find sine theta. Find sine theta. Find sine theta. Find sine theta. An acute angle is an angle that is just less than 90 degrees. That's what it means. So find sine theta. So this is trigonometrical ratio. Please check out our videos on trigonometry. If you're not subscribed to our channel up to this point, kindly subscribe so you can be getting videos of these lessons we have treated in details. It is from there you will now know how to apply them to the questions. So for this particular one, cot theta is a trig identity that is like this. Cot theta is the same thing as 1 over tan theta. This is the identity. And we know that tan theta is opposite over adjacent, right? So if I were to apply these sides to this cot theta, as cot theta, it means that cot theta is the inverse of tan theta, and cot theta is the inverse of this one that is here. So cot theta is the same thing as saying adjacent over opposite. It means that from this relationship that I'm giving here, 8 is adjacent and 15 is opposite. If you compare by similarity, you understand? So it means that adjacent of that triangle is 8 and opposite is 15. So I've gotten two sides. So if I were to draw a triangle like this, and this is theta, you understand? Opposite of it is 15 and adjacent is what? 8. So I can actually look for hypotenuse now with Pythagoras theory. Yes, I can do that. How do I get hypotenuse? H. How do I get hypotenuse? H? H is 8 square plus 15 square all square roots. Please 15, no. Please, pardon the way the marker is behaving. This is 64. This is what? 225. Is it not? Okay. So H is equal to square root of 289. H is equal to 17 by the time you use the square root. So if I've gotten H, that is, I'll come here, I'll put it. I've gotten 3 of them. So how sin theta can be found now? Sin theta is what? Opposite over hypotenuse. Where opposite is 15, hypotenuse is 17. So sin theta is this one. This is the answer. That's the answer. Please check out our video on trigonometry. You will see all these things there where we talk about SOHCAHTOA. Please subscribe so I can be seeing more videos. All right. So We go on to the next one, number 39. Number 39. Number 39. So it says, if the area of triangle PQR below is 12√3 cm square, find the value of Q. Find the value of Q. Okay, so let me draw the triangle below. The triangle below. This is triangle. So this is P. This is P. This is Q. And this is R. This is small q. Pressing this one. Then this one is 8 cm this side. And the angle in between these two is what? 60. There's a formula for finding the area of a triangle given one center angle and two sides that are bounding that center. The area is given as area is equals to 1/2 AB sine big A. Sorry, sine C. Sine C. I will explain all these things, so just don't worry. We're choosing this thing very, very carefully. Let me come here and explain it so that you will know what it is. See, if this one is big A, big A side, big A vertex, big B, and big C. So this one now is big A angle. This is big B. This is big C. So opposite now is one small B, and this one opposite here is now small C, and this one is small A. You understand? Small A. Small A. So if, for instance, is this angle we are looking for that we have, this angle C. I'm trying to write something. Just follow me. If this is what we are given, and we are given these two sides as well, area is half. This is small a, and this is small b, then sine big C. If it's here we are given big A and these two sides, area is half. Then BC over sine big A. And if it's here we are given area is half AC sine big B. So this formula should be followed carefully. That is why, as I wrote this one down, you understand, it applies to this one. But this one here that we have here, it is area is equals to half. You understand? Then 8 times Q sine big P, which is 60. Let me just go ahead and put everything there. Please look at it too. The angle that is given and the area the side boundary is, that's what you are working with. It is half this sine this one. If it this side, half this times this sine here. If you say you are given half this times this sine this one, that's what I've explained in all these things like this. So we are given area as what? As 12√3 is equals to half times 8 times Q is not given times sine 60. Sine 60 is what? √3/2. Sine 60 is what? √3/2. So we can do the math here now. 2 we cancel here, 1, 4, 2, 1, 2. So what I have here is 2 here, 1, 2 here, 6. So I have 6 root 3 is equals to Q root 3. This one will cancel. So Q is actually 6 cm. Q is 6 cm. Q is equal to what? 6 cm. Answer. Answer. So we're progressing. So we're going to a series of differential calculus from number 40. Differential calculus, then we'll enter statistics. Then we'll wrap up the 2010 questions. Okay. So number 40 here says, if y is equals to 2x plus 1 raised to the power 3. If this is true, find dy dx. This question is what we call a composite differentiation. So what for composites, if for instance you have function as a function, there are two functions here. The first one is the linear function where you have this one, a. Let me use u and p. Very good. U is the inner one. U is equals to 2x plus 1. Then y is equals to u cube. So there are two functions here. So this one is, let u be this inside here. So by the time I replace this one by u, I get this one. So this function is actually a function of u, and u is also a function of 2x. But my goal is to find dy dx. So for function of function, what you do for dy dx, there's an intermediate function here that is not needed. That one will disappear. Dy dx, actually, dy dx is the same thing as saying du dx dot, that is dot times, then dy du. By inspection, this u and u will cancel, so that dy dx will be dy dx. But you're not cancelling out, so I'm just telling you now that this u is just an intermediary for this thing to work. We express it as a function because this one now, there's a function inside another function. This is what you are seeing in general. But this u has something inside, which is this one. So this question has two functions, one inside another. The one inside is the 2x plus 1. And this one is inside a bigger one, which is, if this one is taken as one, this in u. So this is the formula for it. So you differentiate the outer function and differentiate the inner function. So, but anything that is expressed in u, let us resolve. If this one is true, like this, dy dx is equals to du dx is this one. Differentiate this one, you have only 2 times. Differentiate this one, it is 3 u raised to the power 2. But nothing, we don't have anything expressed as u in this function, so we just replace it. 2 times 3, u is what? 2x plus 1 all over 2. So the final answer is 2 times 3 is 6. 2x plus 1 raised to the power 2. So very soon we'll upload a video on differentiation. Very soon. So, and how will you get it? If you are already subscribed, you will get it. You'll be the first person to get that video. So we're going to be uploading a video on differentiation. We explain everything. There's what they call the differentiation from first principle, function of a function, the product rule, and so on and so on. You have some kind of equations then there are some identities. Like the next question we're going to see is differentiation of trigonometrical ratios, of trigonometrical functions. So this is the answer for this one. Okay. So number 41. Number 41 says if sine y, if y is equals to x sine x, then find dy dx. So this one is a product rule. There are two functions here. This is a function, x is a function, it's a function, and sine x is also a function of y. So this is product rule. We have done function and function. So it's product rule. Let u be x and v be sine x. So product rule says that if you have y is equals to u dot v, for instance, dy dx is equals to u dv dx plus v du dx. So product rule says that if you have two functions, you just you keep this one, keep it, and differentiate this. This did this plus this did this. That's what you have here. You understand? U is x. So u dv dx plus v du dx. So this did this plus this did this. Did this means it's just a way to make it easier for you to understand. But I've written it down. I've broken it down. I'll define u as x here and define v as sine x. You understand? So for the product rule, you keep this one, as a component and differentiate this. That's why I said did this. Differentiate this dx plus you keep this one and differentiate this other one. Okay, so let's go. Let's write it out here. Dy dx is equals to u. I've kept u. Dv dx, I'm differentiating this one. Sine x differential is minus cos x. Sine x differential is, sorry, it's not minus, it's cos, just cos x. Please check out the upcoming video for differentiation. Then plus v, you keep it. Then du dx is 1. The coefficient of x just 1. We're done. We cannot leave this one like this. We cannot leave u here and v here. Let's go and recall. What is u? U is x. Cos x. Let's recall what's v. V is sine x dot 1. So the answer is cos x cos x plus sine x. So this is the answer for this. That's the answer. Okay. So we'll do one more. Or okay, let's call it a day because of the length of the video. I hope this has been informative for you. I'd like to thank you for viewing.